So I was saying it's a kind of topic that kind of defines me in some senses, so I'm really happy to speak about it. So let's get to it. So, just a quick intro. So you can say that I'm a father of two amazing humans, but also a few quirky artificial minds. So here on the right, on this side, you see a deep neural net playing games. You see AlexNet and BERT Large as lowered in the hardware of a company I was working at until December 2022. And at the top there is just an endearing picture of a chatbot that I'm developing right now called bruaio the Critical, which we'll cover a little bit later on. So, right, so a bit more formally. So I was leading the large model training stability program at GraphCore. This is an AI chip and systems company, and I was doing this until the end of December 2022. Actually, I built my first robot, I think in 1999 it was, and wrote my first neural net in 2003. So over the years, I've explored academia, lived the life of an entrepreneur. I think I'm getting there again, and have also ridden the deep learning wave in the industry. So the thing is, after about 20 years of being in the field, hindsight, the present state of affairs, and the future of my kids growing up in a world where AI capabilities are a first cultural concern, I've basically come to a conclusion in the form of a mission statement for myself to do what I want to do for the rest of my life. And that is to have these AI capabilities, for example, those exhibited by large language models, augment human endeavors reliably and safely. It's kind of a no-brainer, simple thing to think about, but really difficult to implement. But that's what I want to focus on. And that is the main focus at bruaio. It's a company that is not founded yet, but it is about to be. So here's just a little screenshot of bruaio the Critical, this chatbot. It's a research chatbot at the moment, right? So it's not fully reliable. Don't take it as a product yet. Yes. So under the hood, it essentially integrates 50 billion parameter models, and they are not trained by me, just to be clear. I'm using an API. Yeah? And I'll go through it later. And in addition, the thing that I am actually developing is an expanding suite of reliability mechanisms that tap into the capabilities of these large language models in a reliable way. So this session here will delve a bit deeper into the techniques for reliable training as well as deployment of LLMs. So at GraphCore, I was essentially training or pre-training large models, and my job was to make them pre-trained reliably, stably. Or get a team to do that. So while we go through this session content, we will touch upon the good, the bad and ugly, and the useful side of LLM. So basically, there are three things I want to really talk about: the good side, the bad and ugly, and the useful. Right? I might end on a note of optimism. So let's look at the good. All right. Large language model training paradigms are actually in flux. So I'm really happy that there have been great presentations today that have covered most of this. So I don't have to go through this. But what I'd say is that capabilities of these large models are steadily emerging. And that is to say that there is an element of surprise almost when they get unlocked. This we've seen with things like chain of thought prompting. We've seen with things like, say, an instruction fine-tuned model, give it a question, and you just ask it, you just write a phrase, let's think step by step in an answer, and it would reason its way to an answer, say to a mathematical problem. But without the phrase, let's think step by step, it would fail. So there are capabilities embedded in these large models which are untapped, and people are trying to, I mean, there are papers, NeurIPS and ICML papers written about a phrase that one is using in a prompt these days. But there's much more to go here. So I will skip most of this, but let me just briefly say the things I'll be mostly covering. I won't be covering fine-tuning, which was a great presentation just from the previous one. I will cover a bit of pre-training and a bunch of prompting techniques that I've been using for developing what I will talk about, this chatbot. So let's get to it. So I see you're laughing there. So this is basically GPT-3. The other day I thought maybe I should lay out the parameter count of GPT-3 on paper. And the fact that the thing I'm trying to say is that the model is so simple that you could actually lay it out like this and end up with 175 billion as the number. It's really doing very simple things internally. It's just very large and banks on transformer multi-head attention layers, as well as feed-forward, very dense layers as part of the transformer block, which is the central element of transformer-based models, or decoder-based transformer models. So the good side I'm talking about is that there is capability in these kinds of models that can be unlocked if used correctly. Another good thing I want to talk about is it is possible to train these very large models reliably if certain aspects of the training process are considered very deeply. And there are, so my previous employer, GraphCore, we were developing techniques to exactly do this. And with a single line of code in your PiTorch model, oops, I think I missed. So with a single line of code in a PiTorch model, for example, you could enable certain capabilities during the training process. That would be compiler-level capabilities that would then transform the actual graph of the model down to the hardware, integrating various closed loop control mechanisms in order to monitor the gradients, for example, and basically not let them, in our case, underflow or overflow. One thing that is a common practice in deep learning nowadays is we kind of train these models in reduced precision. You can't really use full precision anymore. It's if you train GPT-3 in full precision, I think it would take 700 gigabytes of memory, just the forward pass, and double that if you include the backward pass. That's prohibitive. So people are going lower precision. Half precision is common practice now, but people are going down to 8 bits, even lower. So, and of course, when you reduce the precision, it helps with the compute, the memory, the bandwidth. You don't have to communicate that much across devices. And of course, it reduces the energy footprint to some extent. And because as there was a mention of multiplies, matrix multiplies being the main element of these kinds of models. So multiplies essentially scale quadratically with the number of bits. So if you reduce that, so you can expect a good reduction. So, but when we do this reduced precision training, there's instabilities that come into play. Numbers underflow or numbers overflow, and that destabilizes training. So here's just a training run of BERT large. So I don't know how many times I trained BERT large in the last year, probably 1,000 times, from end to end on our machines, which for 64 chip system from GraphCore would take about 10 to 11 hours. All in order to make sure that eventually come to a set of capabilities that make training reliable. So here's a very common picture. A large model is training just fine for a large number of steps. Maybe it takes numerous hours, and then it fails abruptly. It's just common. So this kind of thing we didn't want. So we did a bunch of research, I would say, and dug into how these different gradients behave internally, and figured that, okay, there are various layers that are at play here. There are various layers which do underflow. For example, if you look at some of those graphs there where there's a big drop, there's a bunch of underflow going on. So better monitor those layers. In fact, we ended up monitoring almost every layer gradients in the graph to make things reliable. So here's one thing we developed, automatic loss scaling. I think people familiar with GPUs are familiar with dynamic loss scaling. This is not like that. This is actually a closed-loop control mechanism. We basically monitored the gradients in the backward pass, and depending on the statistics of the gradients, you scale up or down the loss. Very simple, and works. So essentially, I will not bore you with a lot of the details here, but imagine you're monitoring all the gradients in your large model. You end up kind of putting all those gradients in the same set of bins and end up with one histogram, let's say, of the entire set of gradients, within and across replicas, all summed together. And when you have this kind of a picture of what the gradients are like on this side, just focus here, then you can see what we do is essentially we choose a threshold, that dotted line there, and if there is a certain number of gradients going above that threshold, you want to scale down, otherwise you are nearing overflow region. But you don't want to be very close to the left-hand side here, because that would lead to underflow. So you always tend to keep your gradients as close to the threshold as possible in order to train reliably end-to-end. So here's what we get for BERT large from that picture, where there was no such scaling mechanism, to this picture, where you can see that the gradients are behaving quite nicely across the training. This is the training steps. That's just the histogram, how it looks per training step. They are nicely distributed. And the loss scale, that is the one variable that we are controlling, that changes over time appropriately. So that's the training side, and this feature is released. And if you have access to GraphCore IPUs, which you can get on Paperspace and things like that, you can play with this kind of feature. So that's the training side. Let's come to the bad and ugly. So let's go to deployment. So nowadays, I'm really focused on using these large models properly, right? So here's I'm sorry if there is anyone from Google watching this, but you did make a schoolboy error by releasing something that made an error just during a very, very controlled demo. So I don't know how many are familiar with this. Raise your hands, please. Okay, I will not go through this. So what I'm saying is deploying large language model capabilities systems is notoriously unreliable and unsafe. There are hallucinations that are rife in these systems, and they are made with very high confidence. So trusting these systems is basically an unsolved problem. That's my focus. So I want to do a little quiz here. So that's the system I'm developing. This is ChatGPT. So I asked both these systems a question. How many solar eclipses can happen in a year? Okay, ChatGPT gives me some answer, 2 to 4 on average, but that is a wrong answer, actually. So here is my system. On average, there are 2 to 5 solar eclipses, and there are the sources which it can consult to give you the answer. So which one of these would you prefer? Ideally, I think you would prefer that one, yeah. I certainly would. Here's another one. Try asking the same question, without rephrasing it multiple times. If you rephrase it, then it will probably spit out another hallucination. But here we are. How many exoplanets are known to humanity? ChatGPT gives me various numbers, 4,134, 4,332, 4,000. Of course, it has a cutoff, but still, if it had a cutoff, you should respond with the same number, I guess. Okay, here's a system with access to the internet and various other mechanisms that I'll talk about. Same number all 3 times with the sources. I guess you would prefer that one. So now I actually wanted to look at hallucinations in action. I don't know if I should, because I mean it's kind of clear, but if people want to see some of these hallucinations, we can go through it. Okay, then let's try this actually. So I should mention that I'm connecting my laptop here to the screen, and for the people who are on the stream, the screen will not show now, unfortunately. There are 2 systems here. Okay. Yeah. All right. So, I actually do have a Colab notebook as well, which we can use. So this is just an illustration of hallucinations. This, I must say that this is not, I'm not saying anything here about what the models are, how, I'm not judging the model quality here at all. You cannot judge the model quality through a simple hallucination demo like this. Here's a, okay, so I'll just do this again. So I'm using the capability of few-shot prompting here, right? So I don't have to do that. If I don't do that, it would hallucinate more. But even with the in-context learning ability of large language models, hallucinations are present. So what I'm giving to this model as input is, I'll show you. Okay, let me print out the prompt. Here's the prompt, right? Here are some examples of how a question answering system would respond. Question, answer, question, answer, question, answer. Then you ask the actual question you want to ask. Who is the president of Norway? It's a good question. If you don't know that Norway doesn't have a president, you could ask. And there are people who would ask. So let's ask. Let's see what it says. Right. Okay. It's getting the gist of the thing. I mean, talking about leaders here. So Prime Minister Erna Solberg is the conservative. It's also a bit delayed, a bit out of touch with the reality here. This is just trained on a past snapshot of reality, so it would say that. We could do it again. It would give you another answer. Okay. Wow. Yeah. Harald V, President of Norwegian Parliament. Yeah. Okay, so these hallucinations, I'm just illustrating that these are present. So what I'm trying to get to is that large language models, I personally see them as amazing linguistic masters, linguistic machines with some knowledge, but you don't want to rely on that knowledge. You want to rely on the linguistic capabilities if you want. And that's what I do. I'll show later. But not on the facts. So maybe switch back. Okay. It's very fast. Okay. So I think I can disconnect this. I can let it go, I guess. It doesn't matter. So, okay. The useful. Let's get to the useful bit. So here's the bot I was talking about. I call it bruaio the critical because it has some criticism capabilities inbuilt that I worked on in recent last month. So here's the architecture of this bot. I'll just go through it very quickly. I have like 8-9 minutes. Yeah, great. So essentially, I should be clear about the things that I have developed and the things that I've used from the open source community. So a lot of this is available out there as part of this large language model company called Cohere. They have released a set of applications, including a chatbot, which is grounded in reality to some extent. I use that, but I expand its capabilities with extra reliability mechanisms, and I'm essentially using this as a demo to prove certain points about the things that I want to do in the future, right? So what it does is it takes chat history in. Now you can imagine if you are having a conversational agent, you want to have it respond very contextually. So if it has to respond contextually, it should always try to contextualize the question as well. So you could miss out some context in your conversation, but if it has a chat history, it can recover that context and produce a question that is more meaningful. Imagine questions that you would ask Google. That's what we are aiming at here. So there's a pre-trained model, 52 billion parameters. With few shot prompting, it gets to a nice contextual question, given the chat history. Then there are things happening in parallel, multiple things. One is you get another pre-trained model to sample an answer, just a sampled answer, hallucinated answer. Let it hallucinate. We will use it. We will use it for what it is, a linguistic answer, linguistically kind of proper answer. And then you have another model here, which is an embedding-only model. You could get embeddings of various texts. You do a Google search, get the top results, scrape them, get the paragraphs from them, and you give those paragraphs to this embedding model. You get embeddings of those paragraphs. You get embeddings of the answer, hallucinated answer, and you could kind of find what is most relevant in terms of what looks like an answer inside the paragraphs using a cosine similarity, sort of a dot product similarity of vectors. You could do additional things, and this is what I've been doing. You could imagine that, humans are very good at play, obviously. And we like to play with such systems. So we would ask questions like, who is the president of Norway, when there's no such thing, yeah? So the system should be able to judge as well that this question doesn't really make sense. So this is what I've been building to ensure that the question is also grounded in reality. If it isn't, then it should respond appropriately and say that this may have issues, and Norway does not have a president and things like that. Yeah. So that's another set of things that I've done here. You can basically, what I was saying with embeddings is rank these paragraphs from Google based on the answer. You could also use the question to further fine-tune the ranking, which I do. And then you can give this as context to another instruction, fine-tune the model. And let it answer based on the context. Just tell it, okay, answer the question, that question based on the context you're given. And it would produce something. May not be fully reliable. Same for the, you can use the question as a gating mechanism, this question grounding as a gating mechanism as well. So, okay, so enough said. We can maybe look at a quick demo. Yeah. So essentially, I want to keep AI capabilities on firm ground, so let's try to do exactly that. Okay, just waiting. Okay. Okay. Apologize to people on the stream. You cannot see the slides or what I'm doing here. Oops. I think I should say yes. Okay. So this is I've not done a live demo of Bruaio, the critical, with a big audience yet, so this might fail, but let's see. Okay, so are we connected? Yes, we are. Okay, actually, I wanted to ask the same question as mentioned by one of the speakers, Iris. Yeah, I think you asked ChatGPT, you asked something like this, right? Is vanadium a good conductor of heat, right? So let's see what it does here. I mean, we could go completely wrong, I don't know. Let's be a little brave. Okay, let's see. So, okay, it's typing. Okay, so this is a system in development. So you see, I'm committing things pretty much daily. So I'm printing a bunch of stuff, debugging a lot. So it will take some time to respond, but it is hopefully trying to say hopefully it will try to say something meaningful. Yeah. So what's happening here? Let's see. Should come up pretty much now, unless things are broken. I think it should come up now. Yeah, there you go. So this is what it comes up with. This question may have issues. I'm sorry, vanadium is not a good conductor of heat. Is that right? Yeah, good. You could ask another thing maybe. No, it's okay. Who is the? I don't know. What's the time? Oh, would you ask Google that? Okay, what? Oh boy, is the time? I'm not sure if this will go very well. Let's see. I can show you what's doing in the background. What is the time? Okay. It is asking itself what's the time, and it's searching Google. Wow. I think this is not going to go very well, but let's see what it says. I'm not sure. Okay. Yeah, the time displayed on the home page is the current time in your region. Probably yes. Which home page? I don't know. Yeah, but things like this. So I've been playing around with this actually. So things like okay. Where do we can do a demo later on, yeah. So this is basically what I'm trying to do here. But I'm glad it got the vanadium answer right. So you cannot be fully sure about these systems yet. That's the idea. Okay. So I said I'll end on an optimistic note, right? So let's end on an optimistic note. So really, what I want to say is, you see a lot of green check marks here, because this is true. So Norway is essentially an epitome, in my view. I've lived in India, in the UK, in Norway. Okay, 3 countries, but I can probably judge a little bit about where I want to be, where I want my kids to grow up, right? It's here. So Norway is really the epitome of human values from my point of view. I know it has talent. I have directly worked with people who have developed AI systems that are better than or supersede systems built by DeepMind, OpenAI, Google, NVIDIA. So there is vision here, there's no doubt. My personal ambition is to basically give the world an alternative path in this ongoing arms race, a path with human values. Yeah. So with bruaio, as I call it, basically we want to transform the way humans interact with AI capabilities. We are here for the capabilities to augment human endeavors reliably and safely. We are also here to build a deep tech company in Oslo, right here, and expand the frontier of AI along the way. So we basically strive for a culture where humans and AI work alongside each other and do so with the same trust as you would walk a bridge, hence brua. Yeah. So if you are interested in this, and if you are interested in talking to me or taking this further in whatever way you want, I'm open to opportunities, discussions. Let's talk, and let's shape the future of AI right here.